Would you like to practice some problem types that might be on your middle school grades math exam, like the FTCE, Praxis, TExES, or any other middle grades math exam? Then you're in the right place. Before we begin, go ahead and like this video, comment on this video, and subscribe to the Learning Liaisons YouTube channel. My name is Amy Sink, and I can't wait to go through these practice problems with you. Before we begin, I want to give you some directions that are going to help you be more successful throughout this video. Number one, I'm going to give you 60 seconds to answer each of the following questions. There will be a timer on the screen. When that timer is up, I will go over each question with you. If you want to download a PDF copy of these questions, text the phrase capital YT Math Set 2, YT MATHSET 2 to this phone number on the screen, 407-269-8829. Let's jump right in. Question number 1. What is number 407 in base 4? A, 10131. B, 2110. C, 12113. D, 4034. You have 60 seconds. Go for it. All right, base 4 is kind of an abstract concept for most of us. All of our numbers are in base 10. So to operate in base 4 is a very odd concept for most of us. In order to figure out what the number is represented in base 4, or any base for that matter, we have to divide that number by the base that we're looking for. So if they ask for base 6, we would divide it by 6. We're dividing by 4 because they're asking for base 4. And I'm going to start from the bottom of my page and work up, and you'll see why in a minute. So 407 divided by 4. 4 goes into 4 once. And I'm going to go through my algorithm and divide this out. 4 goes into 7 one time. You have to represent your remainders. That is extremely important in the representation in base 4, or any base for that matter. So I'm going to have a remainder of 3. You're not going to do anything with it yet. You're just going to write it. Now I'm going to divide 4 by 101 because that's the number that's on the top. So 101 divided by 4, and I'm going to go through that same process. And I'm going to represent my remainder. Now I'm going to divide 4 by 25 because that's the number that's on the top. 25 divided by 4. Represent my remainder again. Now I'm going to divide 4 by the number 6. Now I have a number that can't be divided by 4. So now I know that in base 4, which is I divided all of those numbers by 4, I'm going to start at the top right here, and I'm going to cycle down, and it's going to create my number. So my number in base 4 is going to be 1, 2, 1, 1, 3. Because base 4 is a number where we go up to the number 4 and then we start all over. So it would go 0, 1, 2, 3, 4, and then it starts back over again. where in our number set, we go from 0 to 10 and we start over by adding another 10. In base 4, we just keep adding extra 4s, which again, it's a concept that's very abstract for us, but if you can remember this process, you'll be successful on these kinds of problems. So our answer is the letter C, 1, 2, 1, 1, 3. Remember, those remainders are super important in finding out what your answer is in a base of any kind of number. Excellent job. Let's move on. Number 2, Alexander has 2 pieces of wood. One is 90 inches long and the other is 72 inches long. He wants to cut both pieces of wood into smaller pieces so that all the pieces are the same length. If he wants the pieces to be as long as possible and doesn't want to have any lumber left over, how many total pieces of lumber will he have? A, 18, B, 27, C, 9, or D, 15? Go ahead and solve it. You've got 60 seconds. All right, we know that he has 2 pieces of wood. One is 90 inches, one is 72 inches. And he wants to cut those pieces of lumber up, kind of like division. He wants to divide these numbers up, but they all need to be the same length, and he doesn't want to have any leftovers, which is remainders when we talk about division. So, how many total pieces of lumber will he have? In this problem, we're looking for the least common, no, we're looking for the greatest common factor. We're not looking for the least common multiple. We're looking for the greatest common factor, which is the biggest number that we can have that multiplies to give us 90 and 72, because he wants the most amount of pieces without any leftovers. So I'm going to look at these 2 numbers and I'm going to start listing all of the factors. So we've got 1 in 90, 2 in 45, 3 times 30, 4 times nothing, 5 times, and some exams allow you to use a calculator. If you have a calculator, you can use it. So if you don't have a calculator, this is how you can solve it. 5 times 18, and we're going to stop there and start listing the factors of 72 and see what we get. 1 in 72, 2 and 36, 3 and 24, 4 and 18. Look at that. We know that 18 and 18 are both multiples of 90 and 72, which means I can divide 90 by 18, I can divide 72 by 18, and that's the biggest number that each of them have that I can cut those pieces of wood into. However, the question asks us, how many pieces of lumber will he have? Not how big are the pieces. Well, that means that letter A is not correct because the pieces are each going to be 18 inches long. I'm going to get 5 pieces that are 18 inches long out of my 90-inch piece of wood, and I'm going to get 4 pieces of wood that are 18 inches long out of my 72-inch piece of wood. 5 plus 4 is 9, so I know my answer is 9. But they threw that 18 in there to trick us because 18 is actually the greatest common factor. So, excellent job working through that problem. Let's go on to problem number 3. There are 120 students in a middle school. Each year, the population increases by 15%. Which explicit formula generates a sequence of population in this middle school? A, function equals 120 times 0.15 or 15 hundredths to the n minus 1 power. B, function equals 120 times 1.15 to the n minus 1 power. C, function equals 120 plus 0.15 times n minus 1. D, function equals 120 plus 1.15 times n minus 1. Go ahead and solve it. All right, we know that there's 120 students and our population is increasing by 15%. So we know that we're starting with 120 students and we want to find the increase each year. So our formula is going to be our starting number or our starting population. So we'll put an S for start times our percent to the n minus 1 power. N is the number of years that we're looking at. So we know that we're starting with 120, but here's where people make a big mistake. Instead of putting the 1.15, which I'll explain in a minute, most people will just take this percent and throw it in that spot. However, if it's increasing, we want to start with our whole, which is a value of 1, and we want to add that percent to that. So it's 1.15. If we're decreasing by 15%, we're going to subtract 15% by a value of 1 whole, which would give us 0.85. So if this was a population that was decreasing, our answer would look something like this, because we would subtract 15% from a value of 1 whole. But because we are increasing, we're going to add 15% to a value of 1 whole to the n minus 1. N is the number of years in this case that we're looking at. So our answer in this case is going to be B, because we're adding that 15% to the 1 whole. Excellent job. Let's move on to question number 4. Joe and Sarah shopped at the nursery. Joe bought 6 perennials and 2 trees and paid $84. Sarah bought 5 perennials and 3 trees and paid $90. How much did each perennial and tree cost? A, perennial is $15, trees are $9. B, perennials are $9, trees are $15. C, perennials are $12, trees are $6. Or D, perennials are $6, trees are $12. Go ahead and solve it. All right, there's a couple of different ways that we can solve this. We can use algebra to solve it, or we can use our answer choices to benefit us. So we're going to look at both ways to solve it. If we're going to use our answer choices to benefit us, we can literally just take each answer choice, plug it into the problem, and see what we get. So perennials are $15. Joe bought 6 of them. 6 times 15 is 90. Trees are $9. 9 times 2, because he bought 2 trees, is $18. 90 plus 18 is not going to be 84. So I know that that's not going to be my answer. Letter B. Let's solve that one. Perennial is 9. So 6, because Joe bought 6 perennials. 6 times 9 equals 54. And 2 trees cost $15. 2 times 15 equals 30. 30 plus 54 is 84. But I'm not done. Now I have to see if those prices also match Sarah's equation. Sarah bought 5 perennials and 3 trees, and she paid $90. So let's check it. 5 times 9 is 45. And 3 times a value of 15 is 45. 45 plus 45 is 90. So I've found my answer, B. But there's also an algebraic way we can solve it as well. If I wanted to solve this using algebra, I can use a system of equations. I'm going to define my variables as P equals perennials and T equals trees. So if he bought 6 perennials, then he has 6P and 2 trees, and he paid $84. So let's use that same process to figure out the equation for Sarah. So Sarah bought 5 perennials and 3 trees, and she paid $90. Now I have a system of equations, or 2 equations, that I can now eliminate a variable to solve. So I'm going to multiply this equation by -3, and I'm going to multiply this equation by 2, the entire thing. This equation becomes -18p minus 6t equals -252. This equation becomes 10p plus 6t equals 180. All right, now I can add my 2 equations together to see what I get. So -18 plus 10 is going to give me 8p. Now you see why I did this, because -6 plus 6 is 0. That variable crosses out or eliminates. This is called elimination with a system of equations. Equals -252 plus 180 is going to give me -72. Divide both sides by -8, and P is going to equal $9. So I know that my perennials are $9, and my trees, if I take this number and I plug it back into an equation, 6 times 9 plus 2t equals 84. 54 plus 2t equals 84. Subtract 54 from both sides. 2t equals 30. Divide by 2. T equals 15, and my trees are $15. So we can use a system of equations to solve something like this, or we can just use our answer choices to benefit us. Both ways work. Excellent job. Number 5. Amy has a total of $20,000 in 3 different investments. A savings account paying 5% annual interest, a bond paying 10%, and a stock market account paying 13%. She earns a total annual interest of $2,005, and she has 3 times as much invested in the bond as in the savings account. What amount does she have invested in each account? A, savings, $4,000. Bond, $12,000. Stock, $4,000. B, savings, $2,500. Bond, $7,500. stock, $10,000. C, savings, $3,500, bond, $10,500, stock, $6,000. D, savings, $4,500, bond, $13,500, stock, $2,000. Go ahead and try it. All right, we know Amy has a total of $20,000. So the first thing I'm going to do to eliminate answer choices is just make sure that this plus this plus this equals $20,000. And in all four answer choices, it does. So we can't eliminate any answer choices based on that. But sometimes you can. So that's going to be the first thing that I do. Then in this case, I am going to use my answer choices to benefit me. You could use a system of equations to solve this, but because of the percents and it being a 3-variable equation, it's going to take you a really long time to solve this problem using a system of equations. And let's be honest, we just don't have a whole lot of time to solve these problems. So we're going to use our answer choices to benefit us in this example. So we know we have a savings account paying 5% interest, a bond paying 10%, and a stock market account paying 13%. So I'm going to take each answer choice, multiply it by the percentage of interest that we're earning, and then add that interest to see if it's $2,005. So savings account, $4,000. I'm going to multiply 4,000 times a value of 0.05 because that's how this percent converts into a decimal. I have 5% and I move the decimal over 2 decimal places. And I end up getting 20,000. However, I'm going to have to move my decimal place because I was multiplying by a decimal. So I get $200. Bond. I'm going to go ahead and multiply my $12,000 by a value of 10%. And I'm going to move my decimal place, and I'm going to get a value of $1,200. Stock, $4,000. I'm going to multiply that by a value of 13%. I'm going to move my decimal over 2 places, and I get $520. Now, I'm going to add those numbers together and see if I get $2,005. 1,200 plus 200 equals 1,400. 1,400 plus 520 is $1,920. That is not $2,005. So I know that answer A is not correct. Let's go ahead and move on to answer choice B. Now, some tests allow you to use a calculator on a problem like this. Some do not. If you can use a calculator, well, then you can just multiply these in your calculator, which would be awesome. All right, savings, $2,500 times 5%. I get $125. Bond, $7,500. I'm going to multiply that by 10%. Move my decimal over 2 places. I'm going to get 750. So I'm going to add 125 plus 750 plus whatever I get when I multiply the stock by 13%. 10,000 times 13%. Move it over 2 places. I get 1,300. I'm going to add those numbers together and see if I get 2005. I got $2,175. That's not the correct answer either, because remember, we're looking for an interest value of $2,005. Let's check out answer number C. Going through the same process. So $3,500 times 5%, $175, plus $10,500 times 10%, $1,050, plus 6,000 times 13%, $780. I'm going to add those together and see what value I get. And we got $2,005, which means that letter C is our answer. Excellent job! Passing your certification is all about 3 things: knowledge, skill, and attitude. Knowledge is knowing the facts about your test, knowing how much time you have to take, how many questions are there, what percentage of each of the competencies is on that exam. Skills. You have to have proven test-taking strategies for success. You have to know how to analyze each question, how to eliminate answer choices, which will all help you be confident in your practice, which leads us to number 3, attitude. Building your confidence through targeted practice from reliable resources like the Learning Liaisons YouTube channel is going to give you that confidence and the attitude that you need to be successful when you walk into that exam. For more information on how to clear up testing confusion and pass your exam on the first attempt, visit us at www.thelearningliaisons.com. Always remember, it's when you pass, not if you pass. Thanks for joining. I look forward to working with you again soon on some more math videos.